everybody, this is Will from SRT Amplification, and I just wanted to preface this video that you're about to watch by saying that I haven't put out any videos in the last few days. Actually, since Tuesday I haven't put out a video since the last Tech Talk Tuesday, and that's because I had family up here visiting. My wife's brother and sister came up from Texas, along with my wife's sister's daughter, my niece. But they also brought my 4-year-old granddaughter with them, so that was great. Got to spend a few days with her, and she's great. I'm a proud grandpa, so it was really good. My grandsons weren't able to come, but my granddaughter was able to make it, so it was a good week. But I ran into some snags on this BR-6 that you're about to watch a little bit of. And I'm having to totally revamp what I was working on it with. But this should be a short video, kind of just what I'm doing with this BR-6, because I know you guys are out there wondering, what are you doing with that BR-6? And then I should have another Tech Talk Tuesday coming up on Tuesday, and I have an idea for the Hammond AL43, so we should be getting a video on that soon. And then that Westinghouse single-ended amplifier, I've got some things worked up on that, so there should be a video about that coming up soon too. So hopefully we get these projects out of the way, and we move on to some other projects or some customer repairs. So enjoy the video, and as always, thank you. Hey everyone, welcome to another installment of SRT Amplification, and today we're going to be, I think, on the 4th part of this Gibson BR-6, and I found out a little bit more about this amplifier since the last video I made. I was assuming it was the BR-6, and it is a BR-6, but it's actually an iteration after the BR-6, which is the BR-6F. And if you remember in some previous videos on this amplifier, if you haven't watched them, go back and watch them, and then come back to this one. It might make a little more sense to you. But we took this thing apart and we looked inside of it. We checked all the tubes, and we decided that, you know, this thing has no tone control. So it was a little bit bright. It had a lot of highs that you couldn't get rid of unless you you know, took them out with your tone pot on your guitar, which I ended up having to do on the sound demonstration, if you watch that video. Another thing we found was that the filter capacitors had been changed in this thing, and that a three-prong cord had been installed, and so the grounding and everything was good. The only thing that really failed a test was one of the power tubes, one of the 6v6s. So just kind of a little side note here, I went on eBay and I was looking for some new old stock 6v6s, and eBay is not the same site that it was when it, you know, first started as an online auction. Basically, eBay has now become just a, you know, a worldwide Craigslist, really. People now post things with a buy now price on them, and they really don't put their stuff up for auction much. Some of the sellers will have a button that you can, you know, ask for a price, you know, make an offer or that type of thing. But for the most part, they're just selling their stuff for what they're asking for, and that's about it. But I was looking, and I found several pairs of new old stock tubes from the 50s and the 60s. And they were wanting $100 for a pair. That was about the average price for a pair of them. Whether they were RCA, Sylvania, or whatever they were wanting about $100 for a pair. So I kept looking, and I did find a pair that was actually being auctioned, and it had 13 hours left on it, and nobody had bid on them. And the starting bid was $25, so I put $25, and 13 hours later I got a notification saying that I had won the auction, and that the tubes were coming my way. So 3 or 4 days later I got them. So let me take one out here, give you a close-up of it. They are RCA tubes, 6v6s. I think the seller was advertising them as 1958, but I'm not sure about that. Could be. It's probably from the late 50s, early 60s anyway. New old stock in the box, and they both tested about 85 on my tube tester, or one of my tube testers that I used tested about 85. I didn't try them on the other one, just to see what the disparity, the contrast was. But anyway, I put them in there. Oh man, this thing works great. Everything's good, quiet, just no tone control. Okay, so in one of my videos, I put the question out, should I put a tone control in it? Should I not put a tone control in it? I actually got mixed reviews about it. They said, hey, on an amp like this, just leave it alone. But I wanted to prototype something and stick it in the circuit just to see, what it might sound like. There's no space on here unless I used one of these instrument inputs that I could put a tone knob without putting a hole in it. So that was my thoughts. I was going to use one of these instrument inputs and put a tone stack in it. Now every test or every template that I was using for a tone circuit, when I was doing it, when I was drawing it up, I was using the BR-6 schematic. So I had it all drawn up and everything was good to go. I actually came out here to the bench to execute it, just stick it in the... So every design that I had drawn up, and I eventually settled on one, but they all revolved around using the BR-6 schematic. I had it all drawn up and everything, and I was just going to come out here to the bench and prototype it on the bench, just stick it in the circuit temporarily and see what it sounded like, and then I would decide whether or not I was going to, stick it in one of these instrument inputs, as a kind of a reversible way of adding a tone control to it. But when I did that, I actually got it out here on the bench and I started looking at the circuitry of the amplifier itself, and it didn't match the schematic. So I had to go online, and then every schematic I would bring up online was for the BR-6, until I went to the Gibson website, and then I noticed that they had a BR-6F. And when I pulled up that schematic, boom, there it was. Now, let's refresh your memory a little bit about the schematics. Here's the original BR-6 schematic that we looked over. And you notice it's got two inputs. And the actual amplifier itself has three. Well, oftentimes back in this period of time, schematics didn't get updated when they made upgrades to their amps. And I could see that a little upgrade of, adding an instrument input or something like that may have not warranted updating the schematic. So I figured, okay, well, that, it's just another input that's over here and everything operates exactly the same. Well, that's not the case at all. In the BR-6, the one that I was using to put a tone circuit in, I was going to put a tone circuit in between this first preamp stage and the phase inverter. Now, if you'll notice, on the BR-6, the volume control comes before the preamp, and this preamp is a 6SL7, which is a dual triode, and the way they've got it in here, it's in parallel. What I did was I actually split this and put them in series and put the tone circuit in between them in my design. Well, obviously my design won't work because in reality the BR-6F is a totally different circuit. The BR-6F has a pentode, a 6SJ7, as its first preamp stage and only preamp stage. Then it has the volume control. Notice the three outputs, or the three inputs. Then it goes into the 6SN7 inverter, and then into the two 6V6s. Other than that, they're pretty much the same as far as the filter capacitors and rectifier. They're both still 5-watt 3s, and all of that. It's basically the same. But one thing I wanted you to notice is this. This schematic was actually drawn by NCP, whoever that is, on 11 October 1960. Now what's interesting about this is now I don't know if there was a schematic for this prior to 1960, but on the Gibson website this is what comes up. But the BR series was discontinued in 1954. So I'm wondering if, you know, maybe when they made the change from the BR-6 to the BR-6F, which I'm sure one of the reasons they did this is, well, there could have been several reasons why they did this, but one of the reasons they may have just, you know, got a good deal on 6SJ7s and they just changed the design. I mean, that's a likely reason for back then. They could get these tubes cheaper than they could get these tubes, and so that's what they just changed the design of this first preamp circuit. Anyway, but 1960, so for 6 years these amps weren't even made when this drawing was created. So I wonder if, you know, they thought, hey, you know, we never did a schematic for the BR-6F when we made that change. Maybe we ought to go back and put that out, and they just put it back out in 1960. I don't know, but I did trace it out, and this schematic does match the amp that we have here on the bench to a T perfectly. So to make a short video of this, what I want to do, because now I've got to go back to the drawing board and I have to rework a tone circuit in this thing, because I'm no longer splitting the tube anymore, and really and truly I don't know if I'm going to have enough gain off of this 6J7 or 6SJ7 to put a tone circuit in here. So that's going to be another issue, but we'll look at it and see. If anything else, I'll prototype something and then we'll see what it does, and then we'll go from there, but that'll be in another video. But on this video, what I wanted to do was I want to input a signal into this thing, and I'm going to stick it up here, and I'm going to stick it up on my scope here, and we're going to look at it, the output signal on the scope. And then I'm also going to put on the scope for you guys to look at is the ripple in each of the filter stages. If you'll notice, the first filter we're going to look at, or the first stage of the filtration, so this AC is rectified here from the power transformer through a 5Y3 rectifier tube. It goes through a 20 microfarad capacitor in parallel with a part of the fill coil windings, which is an inductor. So we basically have an LC filter here. Then we have a 10 for the second stage of filtration, and so this is for the power tubes, the voltage on the power tubes. For our second stage of filtration, we have a 10 microfarad capacitor to ground in parallel with a 47K resistor, and then we have, and that gives the voltage for the phase inverter. And then for our cleanest DC, which is really what we want, the cleanest DC we can possibly get for our first preamp stage, or our only preamp stage in this case, is a 10 microfarad going through a 200 ohm resistor feeding the plate voltage. And anyway, we'll look at each one of these. Actually, what we're going to do is we're going to look at the first one and see the ripple, and then we're going to go over here and jump to the last one, and you'll see it becomes basically a straight line, and I can go as low as I can go on my oscilloscope, and there's no ripple at all in this thing. It's basically just straight DC. Alright, so let's flip this chassis around and let's connect some probes to it and see what we got. Okay, hopefully you can see what's going on here. I have a 10X probe connected to either side of the first filter cap. And if you'll remember in the schematic, this first filter cap actually goes to ground, and then the next part of this filtration process is through the coil. So none of the coil windings are exposed, so I have to catch this on the other side where it ties back into the positive side of this second 10 microfarad cap right here. So that's what I'm going to do now to show you exactly. But right now what the ripple is showing on here is about, I've got this set to 0.5 volt per division. So we're looking at probably between 12 and 14, maybe 15 volts of ripple riding on that 400 volt DC right now, which not very good even for a power amp stage, but we still haven't went through the coil yet. So I'm going to take this off and we're going to clip it down here to the positive side of this first or the second filter cap, and you'll see how it cleans up a little bit here on the screen. There we go. So there's the ripple that we have, and now I'm on 5 milliamps per division, and that's millivolts, not milliamps. Don't worry, I'll say it again later. Probably a little over 1 division, so 5 milliamps now riding on that 400. So it cleaned it up pretty nicely. Let's go to the second stage across it, and across the resistor. Yeah, let's go to the second stage. Or this will be the third stage, I guess. And across the third stage, I'm getting lower than my oscope will go, so it's a really clean wave. And this probe's not. There we go. Probe's kind of jumping around there because it's not clamped on good. I may have a bad connection right there too, so I'm gonna have to explore that. But as you can see, it's a straight DC line there. It's really clean after that last stage. So let's put our audio signal through here and let's look at the output and see how clean it is. Okay, so I have a 200 millivolt signal going into this at 1,000 kilohertz. I meant to say 1,000 hertz, not 1,000 kilohertz. And I got the probe connected across the speaker terminals, and we'll go ahead and bring this up here. You can probably hear the tone through the speakers. And there's Pretty As You Please. Now, it's worthy to note here that the line on the oscilloscope looks a lot wider than it did off camera. This is because the camera is out of focus. So take that into consideration when you're looking at this. The line on the oscope is actually really thin and crisp and a really good sine wave. Let me turn this down. Right now I'm building a dummy load and it's under construction, or else I would have stuck that on here and then we wouldn't have had to hear this awful noise. I could have turned it up a lot more. But I'm going to go ahead and turn it up a little bit more, and you'll see when it gets to the full range exactly what it's looking like. So it gets really loud without distorting it at all. As you saw in that sine wave, it was just very clean. Once I get that dummy load on there, I'll go ahead and crank her all the way up, see what she looks like on the scope, see when it starts to break up, if it does at all. I don't think it's going to. I had that up around, well, I know it will, because when I did the sound test up around 7 or 8, you could kind of hear it. But I'd like to see what the waveform looks like and see how much clipping it's doing. But anyway, that's the Gibson BR-6F. So I'm going to change that title in the description. And filter caps have been changed out. The power cord has been replaced. It's got a brand new set of new old stock RCA power tubes, 6v6s. That only cost me 25 bucks. So I thought that was a heck of a deal. And this thing really plays great. Aside from the not being able to control the tone of it, it plays really good. I'm gonna, like I said, I'm gonna draw up a prototype for a tone control for this thing, and I'll just have it external until I get it dialed in. And if I think it does something, you know, to the amp that makes it better, I may stick a reversible temporary or more permanent but reversible tone circuit in it, and just utilize one of those instrument cable instrument inputs. So appreciate you guys watching this video. Tried to keep this one shorter than most of my videos, but I know they go long. I should have another video coming out for Tuesday, Tech Talk Tuesday. But if I don't, look for something later on in the week. And as always, I thank you guys for watching my videos. And if you haven't seen my prior videos, go back and watch those. They're all under SRT Amplification. And thank you guys for watching.